So we are finding X and Y intercepts today. So the reason we're doing that is because oftentimes when you're dealing with graphing these things, you want to be able to find the X and Y intercepts, so it helps with graphing. We won't be doing any graphing today, but you can. It's helpful for that. It's also useful in a lot of times when you use quadratics to solve word problems. The intercepts actually tell you something about the word problem you're solving a lot of times. So it's also just kind of like a nice skill builder to review some algebra, how to solve for X and stuff. So that's why we're going to be doing that today. It's just to find these intercepts. It's just a nice skill. It's helpful in a lot of ways. So, well, I'm gonna proceed. You just put 3.2 at the top, though. You can bum it from a number. Now, part A. What are intercepts? What are intercepts? Intercepts are where the graph touches the X and the Y axis. So, for instance, draw something that looks like this. Try to get it to look as much like that as you can. All right, guys, so which axis is the y-axis? The one that goes up and down or the one that goes left and right? Good, so let's put y there and this is x, right? So the place where your parabola touches the y-axis, that is your y-intercept, right? Now, I don't know what the y value is here.
You just draw any.
Yeah, well, I would try to make it look like this as much as you can. I don't know what the y value is here, but we do know the x value. What's the x value?
0.
It's 0. Okay? So, here's something I'd like you guys to write. To find the y-intercept, today I'm going to give you guys an equation, not a graph. I'm going to give you an equation, and I'm going to ask you to find the y-intercept. The way you're going to do that is you're going to plug what in for x? 0. And then you can solve for y. Okay? So to find the y-intercept, you plug 0 in for x. Because when you're on the y-axis, x equals 0, right? Now let's go ahead and take a look at these 2 points here. Bless you. Those are the places where my parabola touches the x-axis, right? Am I going too fast? You guys okay? I'll wait a minute. I don't want to get too quick for y'all. Yeah, sure.
Good shot.
I'm just kidding. I didn't blow my nose. This is the real stuff. Just eat. I wouldn't throw boogers at you, I promise. All right. Okay. So that will be posted on the web for all to hear. Very good. Here we go. So these points are what we call the, what do you think? They're called the X-intercepts. Now, for these ones, there's 2 of them, aren't there? We have one on the left and one on the right. I don't know what the x value is because I don't know how far over this is or how far over that is. So I don't know the x value, but I do know the y value. When you're on the x-axis, what's the y value? Once again, it's 0. So I'm going to write another sentence here. To find the x-intercepts, what are we going to do? That's right. We're going to plug in 0 for y and solve for x. So it's kind of like the opposite. If you want the y-intercept, you plug in 0 for x. If you want the x-intercept, you plug in 0 for y. Okay? And notice that these ones give you 2 answers. Now, just as an additional note, X-intercepts have 3 different names. One name is X-intercept, okay? But they're also called, does anybody know? I'll give you a point if you remember. No. No. Ooh. They are called zeros. Nice job, Danielle. You know what else they're called? She will. They're called the roots. Do you guys remember that from last year? So X-intercepts are also known as zeros and roots. So just know those are synonyms. I don't like the name zeros very much because, I don't know, you could call, why don't they call the Y-intercept a zero, right? Because it has zeros too, right? But roots make sense. I just think of it like a plant, and this is the ground, and that's right where the roots start, right? That makes sense to me. And X-intercepts that's perfect. Yeah, so I don't know, but there's what they're called. So if you ever see a question that says find the zeros, what they're really saying is find the X-intercepts. Or if they say find the roots, what they mean is find the X-intercepts, which means you're going to plug 0 in for y and solve for x. Okay? All right, so there is our definition of what intercepts are. Let's go ahead and do our first example. We're going to start off with something easier. It's easier to find the y-intercept. X-intercepts get a little bit hairier, but y-intercept's a little bit straightforward. So here we go. Find the y-intercept. So let me make up a parabola here. There's a parabola, right? All right. So, how do you find a y-intercept? You plug 0 in for x. Ready?
I'm not ready yet.
All right, Anna, I'll give you like another. We're going to plug 0 in for x. Ready? Excuse me. Thank you, guys. Thank you. Okay, so step 1, plug in 0 for x. Okay, after that, guys, just do Pemdas. What do you do first in Pemdas? So 0 take away 3 is? What's next in Pemdas? Exponents, right? So what is negative 3 to the second power? Positive 9. The negative cancels. What's next in Pemdas? Multiplication. Do you see multiplication here? We do. It's 18. We don't have any division, but we do have addition. So what's that going to be for us? 23. Oops, no comma. And so, what did we plug in for x? And what did we get for y? There's your y-intercept. That's where it would touch the y-axis. Sure. Yeah, well, you might want to get in the habit of writing it as a point where you put what we plugged in first, which is 0. We plugged in 0, and then we got 23. That way you have a point Because later on we might want to graph that point. Not too shabby, no? Not too shabby. I think here's the biggest warning. Follow your PEMDAS. A lot of students want to multiply the 2 first and then square it. You'll get the wrong answer if you do that. You do the squaring first and then the multiplication. Follow your PEMDAS. Parentheses, exponent, then multiply. I think we like to do that because we like to go left to right, but it doesn't work that way. All right, so I'm going to throw one at you guys. Yeah. Let's say this is -1 x plus 2 squared minus 3 equals y. Find for me the y-intercept. First thing we do is we plug in 0. Then we do the parentheses, which would be 2. Then we do the exponent, which would be 4. Then we do the multiplication.
Negative. So it'll be negative. Oh, good job, Joanne.
And that means we get -7. We plugged in 0, we got -7, so there's our y-intercept.
I did that.
Okay, now that's a little bit easier. I'm not saying it's easy, I'm just saying it's easier than the next part. The next part is finding the x-intercept. It's a little bit different. So let's go ahead and do the x-intercepts.
Yeah, but
I'm going to call these ones the pretty answers. For this set, we're going to get answers that come out pretty. Ready? No, they do have some ugly answers. Okay, so go ahead and copy that down if you haven't done so already.
it's actually a male.
Wait.
What the heck, bro?
Find the x-intercept, you plug 0 in for y.
Oh,
Okay.
it's the same exact thing, right?
Well, the way you solve it is a little bit different though. So the 0's over there this time. Yeah, so when you want to find an x-intercept, you plug 0 in for y. So in this case, we have to use some algebra, okay? So I'm going to walk you guys through it. Ready?
Hang on.
The first thing you want to do is whatever number's here, you want to subtract that to the other side, okay? So the first thing you want to do is, and you might want to write these steps down, although I don't want to say subtract only because it could be add, but in this case we're going to subtract 32 on both sides. That's your first step. Okay? Anybody have an idea what you might do next? I'll give you one hint. You're not allowed to distribute because there's a square. That's a no-no. So what's another way to get rid of that negative? You're going to divide it out. Okay? Good job. So divide both sides by -2. Now, what is that? That's going to be 16, I believe. I don't have lead, unfortunately. All right. And now I need to do something. We use that if you like. Can I proceed? Or you still need it? Okay. I'll pause a little longer. That, guys, is a little new maybe, or not so obvious to you. So pay close attention to this step. Is this what we have? X minus 3 squared equals 16? Okay, so here's the next step. The way you cancel out a power of 2 is by, does anybody know? You take a square root. But something happens that's really easy to forget. I'll explain why in a minute, but for now, just take my word for it. You're going to square root both sides because a square root cancels out the 2, right? But, yes, very good. Something very easy to forget here, and I'll tell you why it's there. It's not immediately obvious, is when you take a square root on both sides, you have to put a plus and a minus over here.
What?
You have to put a plus and a minus. I'll tell you why in a minute, but for now, just take my word for it.
Wait.
So what is the square root of 16? 4. Okay? So you square root both sides. Don't forget the plus and minus. On the left side, the 2 cancels out with the root. On the right side, you actually take the square root and don't forget to put a plus and a minus. Okay? Okay. At this point, we're going to write 2 equations. Because x minus 3 can equal what? It can equal positive 4 or it can equal negative 4. So we're going to say split the equation up into 2 there, okay? And over here we're going to add 3. And over here we're going to add 3. So I'll put my last step here as solve. And so your 2 x-intercepts are 7 and negative 1. And what did I plug in for y to get that? Plugged in 0.
Whoa.
I have no idea what they're doing.
We'll probably do another one.
Yeah, but make it faster.
This is all I got.
Okay, we'll probably do another one. Try to keep up with us there. So this is the step to watch out for here. This is kind of a neat thing. Now I told you guys I was going to explain that to you. Okay, so let me tell you why that is. If I gave you guys this, ignore all that. We're done with this problem, okay? I'm just going to make up something new for you now. If I said I had something to the second power equals 4, what's the answer? What? 2 is, right? Because 2 to the second power is 4, right? But couldn't it also be negative 2? Because isn't negative 2 to the second power also positive 4? So that's how it works. When you take a square root, right, you get 2. But it could be positive or negative because the square cancels the negative out like it never was there. So when we undo that, we have to put it back. So anytime you solve by taking a square root, you put a plus and a minus. Huh? Oh, sorry. So let's do another one. How about, I don't know, I should make this one up because I feel like thank you. Okay. So let's do this one slowly together. Okay, go and write this down. It's going to be like a guided practice. I'm going to walk you guys through it slowly. Let you guys do it step by step. I made a boo-boo, guys. Sorry. I made a mistake. Ignore that. Sorry. That's what it's supposed to be. I wrote it wrong. I was thinking of something else.
Or are you tricking us?
No.
Does that mean you give yourself extra credit for having your own mistake?
Yes, but I lost a point for making the mistake, so it's like 1
Or
plus
is
a
this
negative 1
an
equals 0.
Is this like
Huh?
What if this is that was the answer?
Guys, why is 8?
I don't think it'll help.
Why is 9?
All right, ready? Here we go. Step 1, do step 1, go. I'll give you like 10 seconds. It doesn't take long.
Got it. Done. Easy.
I want to find the X-Intercepts.
Wait, what?
I want to find the X-Intercept.
So this one's plugged in 0 for X.
Well, maybe. Leslie, what do we have to do first when we want to find the X-Intercepts? That's right. Plug in 0 for Y. Here we go. Okay. Now I want you guys to do the next step.
I don't know.
You have an example. Try to do it. I know you didn't finish it, but you can use it to do this part at least, I think.
I'm feeling inspired by. Can I do this one?
Okay. Go ahead.
So you're gonna add 8.
That's right. Add 8 to both sides.
That's all I got.
Good. Okay. Go ahead and do the next step.
Do you like wait?
What do you think, Miss Paris? What would you say is the next step? What do you think? Any ideas? Huh? Yeah. You divide both sides by 2. Okay, next step. Just so you guys know, sometimes there won't be a number here in the front, and so you just skip the dividing step if that happens. Okay, here we go. Michael,
Yeah.
what's next?
Use square both sides.
And what special little something happens after I do that?
You gotta add a plus or minus in front of the.
That's right. So the square root of 4 is 2, and don't forget the plus and minus. Okay?
I don't remember this.
Why? I'm just kidding. Good memory. Yeah.
Is there always going to be a plus and minus before?
I think the only exception would be is if you had a 0 over here. Otherwise, there should be. Kiara, what do we do next? Yeah, good. Split it up, right? You're going to do one where it's x plus 5 equals 2, and one where it equals negative 2. And then you solve both. I assume at this point you guys will be fine, so I'm just going to go ahead and work it out from here. So one of those is negative 3, and the other one's negative 7. But I want to write these as points. So see if you guys can write them as points. I'll give you a second there. What do you think, Ms. Robles? If I want to write this as a point, what do I write? Perfect. Because the y value was 0, right? Okay, so I'm going to give you guys one to do completely on your own without me walking you through it step by step. And that will be, I'm actually going to give you 2 in case you finish early and you want a little bit of an extra challenge there. The first one is going to be negative 2 parentheses x minus 3 squared plus 32. I already did that one. Never mind. I did that one for you earlier. 3x plus 1 squared minus 3. And then as a challenge problem, 1/2 x squared minus 8. Oh, you will. So that's for you guys. That's student practice 2. And I'm going to give you guys like, I don't know, like 3 minutes. If you can only do one, that's fine. I just put the extra one up there to challenge people who feel like they're, you know, too easy. So that's that one. Yeah. All right. So now this is what I called the pretty answer example, because your answers, can you go that? Yeah, go for it. Is somebody out right now? Oh, can you wait for Henry to get back to us? I call this the pretty answer because you get just normal numbers. Because you could actually end up getting funky looking numbers, and that's what we're going to look at next. Okay? All right. So let's go ahead and take a look at a few there. I'm going to do a couple of examples here. Let's do example 3A. Ready? Annie? That's fine. Okay, we're still finding x-intercepts, guys. Ready?
Oh, yeah, so many things happening.
What?
So many things happening.
So if I want to find the x-intercept, first thing I'm going to do is I'm going to plug in 0 for y. What's the next thing I do? Add 5 over. Henry,
What's up?
trying to teach, buddy. What's next? Square root both sides. So over here, these cancel, right? And over here, is there a square root of 5 that's nice? No, that's an irrational number. So this is what you get. And this is where things get a little bit different. Okay? You could still split this up if you want to, but you just can't take the square root of 5. So you can do this. You can say x minus 5 equals the square root of 5. And x minus 5 is equal to negative square root of 5. What would I do next? Yeah. Oh, I made a boo-boo. Thank you, Heidi. This is supposed to be a 4, you guys. Sorry about that. So, now what do I do to solve for x? Hello? Nobody knows. All right. So you add 4 on both sides. Now here's the thing, guys. You can't add the 4 to the square root of 5. So what we do is we just write it like this. 4 plus the square root of 5. And you can see why we call that a ugly answer now, right?
I mean, yeah, but there's an answer. So.
What would this be?
Minus the square root of negative 5.
Just 4 minus the square root of 5.
But can't you do the I?
We'll get to one like that, yeah.
What?
Oh,
Wait.
whoa.
All right, so I'll leave that up there for like another 15 seconds. I'm going to show you another example. I'm going to do 3 examples. This is our first one. And I just want to show you guys 3 different things that could happen in the process of finding roots, okay? Are we good? Do another one. This is going to be 3b. 3b. 3x squared minus 36 equals y. All right. What do we do first if I want to find the x-intercepts?
Plug it into your Y. I mean, bro. 0.
Thank you, Nelson. All right, plug 0 in for the y. Yeah.
And you add 36.
Now you add 36.
Thank you, Henry. Oh, yeah, the cover.
Thank you, Henry. Well, you're being rude to him. I felt I had to validate him because you were being rude. Nobody's being rude to you. All right, now what? Not yet. Divide first.
Wait, where are we at?
Oh, wait. No. What's 36 divided by 3?
Like
12.
12.
Now what? Square root both sides. And don't forget your...
So, mama,
So what makes this problem different than the last one?
we
Here it is. Yes?
don't have to have two different.
That's good. You're right. I wasn't thinking of that, but you're right.
Okay.
Here's what I was thinking of. We have to simplify our square root. Okay. Help me break it down, guys. What's 12 make?
2, 6, and then 2 and 3, and then 2 radical 3. Shut up.
So it's 2 times 2 times 3.
Those make babies and then one says
That's right.
yeah.
Right? And so here's my final answer.
Baby turtle.
So the question is, do you need to simplify your roots if you can? And the answer is yes. In the last example, I just had 5. You can't do anything with that. So you have to leave it as square root 5. But this one, if you can break down your roots, you need to. Okay? I'm going to do one more example with you guys. Natalie, why aren't you taking these? Yeah. No, you're not. You're taking a siesta, bro. All you need is a sombrero.
What?
All right. Here we go. Next one. Last one. No participation points today?
What?
You want to lose those points today? You better take notes with me, girl. All right. 3C. Here we go. We have 2x minus 4 squared plus 16 equals y. Henry, pay attention and take notes.
Look,
Small
Dad,
child.
I called you Dad. Oh my gosh.
All right. Step 1. I'm going to call on you guys for this because you guys got this. Nelson, what do I do first? He's good. He's got this. Adrian Hernandez, what's next?
Minus 16.
Minus 16, good. John Chavez, what's next? Okay. Let me try another person here. Adrian Canizales, what's next?
Don't you?
Okay, go ahead. What do you think, David? That's right. Divide both sides by 2.
Wait,
That's weird. Okay, next one, Chris. What's next, Chris? That's right. Nice job. So now I've got this. Okay. Now we get to the interesting part. What's interesting? It's an I. Yeah, it's an I. So first of all, we take the I out, right? And then we break it down. What makes 8?
2 and 4 and then 2 and 2, and then this 2 radical 2. Wait, what the what?
What can I have? Take out? Mommy turtle, daddy turtle have a baby turtle, and they leave.
2 eyes, and then they leave.
Okay, so because
Do you guys know what this answer means? If your X-intercepts are imaginary, do you guys know what that means? It means your parabola doesn't touch the x-axis.
Oh, that's weird.
They're imaginary, they're not real.
imaginary is so
All right, but we're not done yet, right? We need to split this up. Is anybody still writing this slide?
no.
Okay. You know what I'll do is I'll start writing it up here. And that way somebody's still writing on the bottom. They can still see it. Okay, so in this case, what do we do at this point? I'm going to call on somebody for this. Eric, what do we do here? Huh? Maybe. If by divide you mean this, split it up, then yes. If you meant something else, then no. But I just call it splitting up. Almost. One more step. Augustine, what's next? I'm up here. I want to get x by itself. Okay. Let me try another person here. How about David? What do you think, David? I want to get x by itself. Okay, someone know? Go ahead, Heidi. You add the 4. Now, can I actually add 4 to this thing?
No.
You can't, okay? So here's the most common mistake. People are going to add that 4 to that 2 and get 6. I just know it. It's going to make me so sad. You don't do that, okay? You can't. They're not like terms. So it's going to be 4 with a positive 2i root 2. That's how you write your answer, okay? It looks ugly, so it's like Henry, but we're going to go ahead and just write it just like... Sorry, son. Sorry, son. You're a very handsome young man. Take after your dad. All right. Same thing over here. So in this case, what that means is it actually doesn't touch the x-axis at all. Okay? You will see a few examples like that in your homework. Okay? Here's what I'd like you guys to try to do. I'd like you guys to try one.
Is the homework gonna be like 1 through 4 or something?
Homework is going to be like 0 through 1,000,000.
Wow.
Dude, that's hot.
I won't do that. So we staple the word to the
See if you can get that answer. I'll give you about 3 minutes-ish.
staple the word to the answer.
Make it pretty.